So here common base is there. When you have a common base, we can equate the index number. What is indices? The plural form of index number is called indices. For the second law, a to the power of m divided by a to the power of n. If m is more than n, hello, my dear boys. Welcome to Vidhyaashram, and we are going to start your fourth semester. I am going to hand your quantitative techniques, nothing but a mathematical. Don't worry about this. Mathematics is considered is a beautiful subject where through your knowledge, you are what's called thorough with this. Don't worry about the mathematics base is considered. It's a technique they are used. So actually what is quantitative technique? No, it is a mix of mathematical and statistical data and make the simplification is there. So we start today with this basic ideas of quantitative mathematics. Techniques are considered. It's nothing but one more mathematics. Very, very good thing for you. When you go for higher study, definitely it will help you. The first chapter goes Indices and Logarithms. We'll start today. What is indices? The plural form of index number is called indices. What is indices? The plural form of index number is called indices. Assume that if we write like this, a to the power of m, when you say a to the power of m, when you write this, no, m is the index number, a is the base. Where a is the base, m is the index number. The plural number of the index number is called indices. We can write like this also. A can be multiplied how many times? M times. A can be multiplied by m times. If we write like this, example, 2 to the power of 4. So 2 can be written on how many times? 4 times. 2 into 2 into 2 into 4. That is now 4 times we can write. Number of times 2 can repeat 4 times. 4 is called the index number. 2 is called the base. Means for an index number to the base is 2. We can say the plural form of index number is called indices. So if we write like this, a to the power of n. So n is the index number, a is the base. A is the base, n is the index number. The plural number of the index number is called indices. We have got certain laws for today. We are going to deal only indices. We have got certain laws for indices. We'll go one by one slowly. Here the first law says a to the power of m, a to the power of n is a to the power of m plus n. Here, when we have got a common base, index number can be added is a law. Here, what is a common base? A to the power of m, a to the power of n. So by chance, if the word goes a to the power of 4 into a to the power of 3, this is nothing but a to the power of 4 plus 3. This is a to the power of 7. But if the number goes like this, a to the power of 3, b to the power of 2 cannot be added because a belongs to one caste, b belongs to another caste that cannot be added. So both belongs to same caste. If this word goes b to the power of 2, b to the power of 3, this is nothing but b to the power of 5. 2 plus 3 because they belongs to same caste. Any same caste can be added, but different caste cannot be added here. AA can be added, BB can be added, CC can be added. Common base, we can have the common base like this also. 5 to the power of 4, 5 to the power of 3, which is the common base, same caste 5. This is 5 to the power of 4 plus 3. This is 5 to the power of 7. We can recite. So when you have a common base, index number, index also say exponent also we can say exponent can be added is a law. Here what's the base? A is the base, a to the power of m, a to the power of m, a to the power of m plus n. If we take 2 to the power of 3, 2 to the power of 2, here which is the common base 2 to the power of 3 plus 2, 2 to the power of 5, that is your 32. So here common base is there. When you have a common base, we can equate the index number. Our index number can be added is a law. Our exponent can be added is a law. The plural number of the index number is called indices. This is the first law. So when you have a common base, exponent can be added or index can be added. So for a to the power of m, for m, a is the base. For n, a is the base. A to the power of m plus n. This is 2 to the power of 3. 2 to the power of 2 is 2 to the power of 3 plus 2, 5. We can have another example. 2 to the power of 4 into 2 to the power of 5. This is 2 to the power of 4 plus 5 means 9. So expand 2. Now how many times it is come? 2 has been expressed how many times? 9 times. 9 times expressed. 2 can be expressed how many times? 9 times can be expressed. This is the first law. Second law goes a to the power of m divided by a to the power of n. What is second law? A to the power of m divided by a to the power of n. If m is more than n, if m is greater than n, then we can say a to the power of m minus n. If n is greater than m, 1 over a to the power of n minus m. So a to the power of n, a to the power of m, if m is greater than n, if m is greater than a to the power of m, if you take the power, plus power becomes the minus power. Only power will be changed. Index number is only a power only. So m minus n. If n is greater than n, 1 over a to the power of n minus n. If for example, see that 2 to the power of 5, 2 to the power of 3 is there. Which is greater 5? You take the 3 that side. 2 to the power of 5 minus 3, that is equal to 2 square is equal to 4. If you have got a 5 to the power of 2 divided by 5 to the power of 4, which is more? 5 to the power of 4 is more. You take down 1 over 5 to the power of 5 minus 4, 5 into 4 minus 2, 1 over 5 square, that is equal to 1 over 25. So what is the first law? A to the power of m, a to the power of n is equal to a to the power of m plus n. When we have got a common base, exponent can be added. What the second law says? A to the power of m divided by a to the power of n. If m is greater than n, a to the power of m minus n. When n is greater than m, 1 over a to the power of n minus m. That second law goes. Then third law, a to the power of m to the power of m. That is a to the power of mn. Multiply m into n, mn. You must be very careful. No, this is very, very important. Here I will tell you. A to the power of m to the power of n. You can say that a to the power of 4 to the power of 2. Another a to the power of 4 to the power of 2. So what's the difference? No, this is 4 2s are 8. A to the power of 8. This is 4 square. This is a to the power of 16. If you remove the bracket, it is 4 square. If it is in the bracket, 4 into 2, mn. See that a to the power of m is m into n is mn. 3 square, 2 4s are 8. Here also same example, a to the power of 4, 2, a to the power of 4, 2. Another example, you can see that a to the power of 3, 2, a to the power of 3, 2. So what's the answer? A to the, what is mn? A to the power of 6. What's the is here? A to the power of 3 square is 9. You must understand this point. Even you remove the point, 3 square will come. Even there is no when you have a bracket, no, it is 3 into 2. That's all. Here, formula is a to the power of m to the power of m is equal to a to the power of mn. Then fourth law, ab to the power of m. M belongs to a, m belongs to b also. This is a to the power of m into b to the power of m. So for example, 2 into 3 to the power of 5, 2 to the power of 5 into 3 to the power of 5. Then fifth law, a divided by b to the power of m. So m belongs to both numerator and denominator. A to the power of m divided by b to the power of m. For example, 5 divided by 4 to the power of 4. This is nothing but 5 to the power of 2 divided by 4 to the power of 2. 5 to the power of 2 is 25. 4 to the power of 2 is 16. So you must be very, very careful here. A divided by b to the power of m. A to the power of m divided b to the power of m. 5 divided by 4 to the power of 2. 5 to the power of 2 divided by 4 to the power of 2. 5 to the power of 2 is equal to 25. 4 to the power of 2 is equal to 16. So all the law you must have a pakka format. What is the first law says? A to the power of m into a to the power of n, it's a to the power of m plus n. When you have got a common base, exponent can be equated, exponent can be added, but you must have a common base. You must be, it will both belongs to same caste. A and B cannot combine together. If the same formula goes, a to the power of b, c to the power of n, it cannot be a to the power of b plus n, because this belongs to one caste, this belongs to another caste. Both should be belongs to same caste, either AA or BB or CC or DD. So when you have got a common base, exponent, index number can be added. Second law, a to the power of m divided by a to the power of m. If m is greater than n, then a to the power of m minus n. If n is greater than m, 1 over a to the power of n minus n. So if you have got an example, 2 to the power of 5, 2 to the power of 3. So here, this is m, this is n, m is more. 2 to the power of 5 minus 3, 2. This is 2 square is 4. This is 5 square divided by 4. So denominator is more. So 1 over 5 to the power of 5 minus 4 minus 2. 1 over 5 square is 25. Then we'll go to the third law. A to the power of m to the power of n. This is a to the power of mn. So 3 to the power of 2 to the power of 4. 3 to the power of 8. If we remove the bracket, it's quite different. I have explained you. Then fourth law, a into b to the power of m, a to the power of m into b to the power of m. So 2 into 3 to the power of 5, 2 to the power of 5 into 3 to the power of 5. Then a divided by b to the power of m. So m belongs to a also, m belongs to b also. This is a to the power of m divided by b to the power of m. 5 divided by 4 to the power of 2, 5 to the power of 2 divided by 4 to the power of 2. So we'll go to problem now, very, very simplification form, and you must have a common base. We'll start the problem. Simplify. So when you want to simplify, we'll take the base of 2, then base the base of 3, then base the take of 3, then we'll go to 4, then we'll go to 5. Here, see that first we'll go to the base of this. What is 4 is, we can write 2 square to the power of 3. Then you can write 256 in the form of 2. 2 2s are 4, 4 2s are 8, 8 2s are 16, 16 2s are 32, 32 2s are 64, 64 into 2 is 128, 128 into, that is 256. How many times? 2 to the power of 8 times. To the power of 1 by 4. This is second formula, a to the power of m to the power of m. This is also same thing, a to the power of m to the power of n. Then 343 is there. Here in the bottom 7 is there. Convert into 7. So 343 is 7 cube now. 7 7s are 49. 49 into 7 is 343. This is your 7 cube. Then this is a to the power of m to the power of n. This is 2 to the power of 9. Come back here slowly. This is 7 square. 49 you can write as 7 square to the power of 1 by 2 into 16. 2 2s are 4, 4 2s are 8, 8 2s are 16. It is converted to the base of 2 to the power of 4 to the power of 1. Then 4 we can write 2 square to the power of 1. Then in mathematics, no, this should be learned. Here result, no, anything to the power of 0 is 1. Anything to the power of 0 is 1. 5 to the power of 0 is also 1. 1000 to the power of 0 is also 1. Then another, no, a to the power of minus m can be written as 1 over a to the power of m. Then m root of a to the power of n. A to the power of n into 1 over m. Cube root of 25. 25 into 1 by 3. By chance, if you have got a root 8, this is 8 into 1 by 2. Root of is 8 into 1. So, fourth root of 25, 25 into 1 over 4. Cube root means 1 by 3. Square root means half. Anything to the power of 0 is 1. It may be any number to the power of 0 is 1. A to the power of 0 is also 1. 5 to the power of 0 is also 1. 1 to the power of 0 is also 1. 1 lakh to the power of 0 is also 1. Come back to our problem. 7 here. 7 to the power of 0 is also 1. We'll go simplification. This is AM. This is 2 to the power of 6 into 2 to the power of 8 into 1 over 4. This is 7 cube. This is 2 to the power of 9 divided by 7 square in 7 to the power of 2 divided by 2. 2 ones up. This is 2 to the power of 4. This is 2 to the power of 2 into 1. Simplification, just a simplification. So take the base of this. We'll go to next one. This is 2 to the power of 6. This is 4 2s are 8. This is 2 to the power of 2 into 7 cube. Then 2 to the power of 9. Then 7 square. 7 square. Then 2 ones are 2. This is 7 to the power of 1 into 2 to the power of 4. 2 to the power of 2 into 1. Take the common base, which is the common base is 2. You can write 2, 6 plus 2 plus 9. This is plus 4. This is plus 2. When it comes now, this becomes minus 4. We can write once again. We can write 2 to the power of 6 plus 2 plus 9. When it comes this way, this becomes minus 4, minus 2. Here minus 4. This is 2 to the power of 2. See that once again if you want. Here 2 3s are 6. 8 into this is I have written 2 to the power of 8 divided by 1 by 4. 4 2s are 8. 2 to the power of 8 is 256. 8 into 1 or 4. 4 2s are 8. This is 2 to the power of 2. 7 cube. This is 7 cube. 2 to the power of 9. 7 square. The 2 into 1 of 2 means 2 into 1 by 2 is the 2 2s are 2 in. This is nothing but 7. 2 2s are 4. 7 to the power of 1. Then 2 to the power of 4. Then this is 2 to the power of 2. You take the base of 2. 2 to the power of 6. 2 to the power of 2. 2 to the power of 9. Minus 4. Minus 2. Into. You take the 7. 7 to the power of 3. Into 7 to the power of minus 2. Into 7 to the power of minus 1. Simplify this. This is 6 plus 2, 8. 6. 6 cancelled out. This is 2 to the power of 11. Then this is 7 to the power of 0. This is 2 to the power of 11 into 1. Once again, I will explain. This is 2 square into 3. 2 3s are 6. This is 2 to the power of 8 into 1 by 4. 8 into 1 by 4 is 2. 2 square. 7 3. Then this is 2 to the power of 9. This is 7 square. 49 is 7 square into half. 2 2 cancel. 7 to the power of 1. Then 4. 2 to the power of 4. 16. Then 4 square is 2 square. Here this is only thing now. This is 2 to the power of 4. This is 2 square. Then this is 2 square. 4 to the power of square is also there. Then 1, come back here. 2 to the power of, this is 4. If we come to that line, 2 to the power of 6, this becomes 4. So 4 plus 4, 8. We can strike off these once again. 2 to the power of 6 plus 2 plus 9 minus 4 minus 4. This is 7 to the power of 3, 7 to the power of minus 2 into 7 to the power of minus 1. So 6 plus 2 minus 4 minus 8 gone. It is 2 to the power of 9 minus 2 minus 1 minus 3. So it will cancel out. It is 7 to the power of 0. This is 2 to the power of 9 into 7 to 1. The answer is 2 to the power of 9. So any number of times we can retain this 2 to the power of 9. Slowly we can do this. Slowly we can arrive. Then we'll go to next problem. This is 2 to the power of m plus 1, 3 to the power of 2m, 5. This can be written as 2 into 3 to the power of n. This is 2 into 3 to the power of m, 2 into 5 to the power of n plus 1, 3 into 5 to the power of m. Simply we can do that. We can simplify this. 2 to the power of m plus 1 into 3 to the power of 2m minus n into 5 to the power of m plus n plus 1 into, this can be written as 2 into 3 to the power of n divided by, this can be written as 2 into 3 to the power of m. This can be written as 2 into 5 to the power of n plus 1. This can be written as 3 into 5 to the power of m. I made simplification by taking the bottom as a 2. Make the simplification. This is 2 to the power of m, 2 to the power of 1, same I have written, 3 to the power of 2m minus n into 5 to the power of m plus n plus 1. This is 2 to the power of n into 3 to the power of n divided by ab to the power of m, 2 to the power of m into 3 to the power of m into, this can be written as 2 to the power of n plus 1 into 5 to the power of n plus 1. This can be written as 3 to the power of m into 5 to the power of m. Simplify all these, go to simplification. All written has been 2 and 5. Then we'll go with the 2. 2. First one, m plus 1. This over, this one. Then come back here. 2, 1 plus n. Here, come back. Minus m. If we come numerator, minus n minus 1. Minus n minus 1. Plus n become minus n plus 1 become, any 3 is there? No 3. So 3 is over. All 3s are over. All 2s I have taken. Now go back to 3. Now we'll go to 3 now. 3 to the power of 2m minus n. 3 to the power of 2m minus n. This over. Then plus n. This over. Come back. Minus m. Come back here. Minus m. This goes in favor of, Then come back to 5. 5 to the power m plus n plus 1. M plus n plus 1. This one. Come back here. So minus n minus 1. Minus n minus 1. Plus n become minus n minus 1. Here minus m. See that? M cancelled out. N cancelled out. Plus 1 minus cancelled out. It is 2 to the power of 0. Then n cancelled out. Minus m minus n minus 2m plus 2m cancelled out. This is 3 to the power of 0 into cancelled out. N cancelled out. 1 cancelled out. This is 5 to the power of 0. I told you anything to the power of 0 is 1. This is 1 into 1 into 1 is equal to 1. Proved. Slowly you have to go, that's all. Slowly you have to go. Then move on to next problem. Problem number 3. It is 5 to the power of 2m plus 3, 10 to the power of 4m plus 1, 25 to the power of 3m plus 2, 16 to the power of m minus half. Simplify this. 5 to the power of 2m plus 3 into 2 into 5 to the power of 4m plus 1 whole divided by 5 square to the power of 3m plus 2. This is a to the power of m to the power of n into 2 to the power of 4 m minus half. This is nothing but am to the power of n, a to the power of mn. Slowly we can do. This is 5 to the power of 2m plus 3. This is 2 to the power of 4m plus 1 into 5 to the power of 4m plus 1. Come back here. 5 am to the power of n. 2 3s are 6m. 2 2s are 4. This is multiplied by 4. 2 to the 4 into m, 4m minus 4 into half. This is minus 2. Take down to this. Next step. 5 to the power of 2m plus 3. 5 to the power of 2m plus 3. 2 to the power of 4m plus 1. 2 to the power of 4m plus 1. 5 to the power of 4m plus 1. Whole divided by 5 to the power of 6m plus 4 power into 2 to the power of 4m minus 2 2s are 4 minus 2. You take the base of 2 now. 2 to the 4m plus 1 minus 4 plus minus 4m minus 2 become plus 2. Come back to 5. 5 to the power of 2m plus 3 plus 4m plus 1 because common base. If you come this now, minus 6m minus 4 minus 6m minus 4. Then simplify this. 4m cancelled out. This is 2 to the power of 3. This is 2 plus 6, 4m cancelled out. 3 plus 1, positive 4, negative 4 cancelled out. It is 5 to the power of 0. What is 2 to the power of 3? 2 2s are 4, 4 2s are 8, into 1 is 8. Very simply, we have clarified that. Very simple we are going. Very simple. Simply we have to make the sheet for this. Hope you understand. Simply I am bifurcating. Go to next problem. Fourth one. 2 to the power of n, 10 to the power of m minus 1, 6 to the power of m minus n, 15 to the power of m plus n plus, this is minus 2, 4 to the power of m, 5 to the power of 2m plus n, into 9 to the power of 9m minus n. Simplify slowly. 2 to the power of n, 10 can be written as 2 into 5 to the power of m minus 1 into 2 into 3 to the power of m minus n, 3 into 5 to the power of m plus n minus 2 divided by 2 square to the power of m. Simplify. 5 to the power of 2m plus n. This can be written as 3 square to the power of m minus 1. I have simplified to the base of 2 to the base of 3. This is 2 to the power of n, 2 to the power of m minus 1 into 5 to the power of m minus 1 into 2 to the power of m minus n into 3 to the power of m minus n into 3 to the power of m plus n minus 2 into 5 to the power of m plus n minus 2 whole divided by 2 to the power of 2m, 2 to the power of 2m, then 5 to the power of 2m plus n into, multiply 2 into m, 2m minus 2. 2 into m, 2m plus into minus minus, 2 into 1 is 2. We'll go to common base now, 2. 2 to the power of n plus m minus 1, this over, then plus m minus n, this over, nothing, come back. Plus 2m become minus 2m. This goes in favor of 2. Then in favor of 3, 3 to the power of m minus n, this over, 3 to the power of m plus n minus 2, m plus n minus 2. So this over, this is minus 2m plus 2, minus 2m plus 2. This goes in favor of 3. Then in favor of 5, 5 to the power of m plus n minus 2, minus 2m minus n minus 2m minus n, minus 2m minus m. Here n cancelled out, minus m minus 3m minus 2, this become 2 to the power of minus 1 into 3 to the power of 0 into 5 to the power of minus m minus 2m minus 3m minus 2m minus 3m minus 2. So this can be written as 1 by 2 into 1 into 5 to the power of minus 3m minus 2. This is simplification. So 1 over 2, this is 2 to the power of minus 1. So it's come here, 1 over 2, 3 to the power of 0, 5 to the power of 3m minus 2. We can write this now, 1 by 2 into this one, 5 to the power of 3m minus 2. Fifth problem. Slowly we can go. This is 5 to the power of minus 1 into 7 square, 5 to the power of 2, 7 to the power of minus 4 into 7 by 2. Simplify these, you take the 5 one side, 5 to the power of minus 1 plus 2 becomes minus 2. This can be written as 7 to the power of 2 minus 4 becomes plus 4 to the power of 7 by 2. This can be written as 5 to the power of minus 2. If it goes minus 3, this is 7 to the power of 3. Minus 5 becomes plus 5 to the power of minus 5 by 2. Simplify. This is 5 to the power of minus 3 into 7 to the power of 6 whole to the power of, this is 7 by 2 into 5 to the power of 5, 7 to the power of 8 whole to the power of minus 5 by 2. Simplify. This is, here also 5, here also 5 is there. This is 5 to the power of minus 3 into 7 by 2, 7 to the power of 6 into 7 by 2, 5 to the power of minus 5 into minus 5 by 2, 7 to the power of 8 into minus 5 by 2. What I did know, 5 to the power of minus 1, if we take 5 to the power of minus 2, 7 to the power of 2, minus 4 become plus 4, 7 to the power of 6, which I have to 5 to the power of 2, 5 to the power of minus 3, 7 to the power of 3, 7 to the power of 5, then minus 5 by 2, 5 to the power of minus 3, 7 to the power of 6 to the power of 7 by 2, 5 to the power of minus 5, 7 minus 2. Simplify this. This is 5 to the power of minus 21 by 2. This is 2 3s are 6. 7 to the power of 21. This is 5 to the power of 25 by 2. This is 2 4s are 8. 7 to the power of minus 20. We can take the 5 at a stretch. 5 to the power of minus 21 by 2. 5 to the power of minus 21 by 2 into another 5. This is 5 to the power of 25 by 2 into 7 to the power of 21 into 7 to the power of minus 20. Simplify this. This is 5 to the power of, if we take the LCM 2, minus 21 plus 25. This is 7 to the power of 21 minus 20. This is 5 to the power of plus 4 by 2 into 7 to the power of 1. This is 2 2s are 5 square into 7. 5 5s are 25 into 7. So 25 into 7, 25 into 7, 175. This is the answer. So 175 is the answer. Hope you understand this. What I did, I think once again, 5 to the minus 1 minus 2 I have taken, 7 2s I have taken. I took the simplification, one side 5 5, then make the simplification 5 2 as a base, minus 21 plus 25, 21 by, so this is 4 by 2, 7 to the power of 1. This is 2 2s are square, 5 square into 7, 175. I have done about the 5 problems, all practical problems you have solved. In the next session, we'll go with the basic of another problem. We'll have entered to another problem of same type. Indices will solve another 5 problem in the next session. Till then, goodbye. Meet in the next class. Thank you. Thank you once again. We'll meet in the next class with indices. Till then, goodbye. Meet in the next class.